Hi everyone, welcome to my channel Edu-spectra. So now, today let us start off with the next chapter in class 9 maths, which is chapter number 2, polynomials. Okay, so now from our previous classes onwards, from our lower classes onwards, we have been learning about algebraic expressions. Okay, so we know if I say for example 2x and all, we know that this term, this x term, we call it as the variable. Okay, we know we call the x term, y term, etc. as the variables, and this as we call it as the constant term, or we can call it as the coefficient. Okay, we can also call it as the coefficient of x. So all these things we have been learning from our lower classes. Similarly, if I write 2x square plus 4y plus 2. Okay, so you can see over here. Here x is your variable. The coefficient of x square is what? 2. Similarly, here y is the variable. Here y is the second variable which I have written, and the coefficient or the constant term of this y is 4. Okay, and this is okay. So all these things about algebra and its expressions and all we have been learning from a lower classes itself. So now we have to learn what a polynomial is. So when I say about so polynomials are algebraic expressions whose exponent of the variable are whole numbers. So now what does this mean? Okay, here I have written a few examples of an algebraic expressions. So just see the first one. Here the first one I wrote is 2x. Now just observe the exponent, the power of the exponent over here. We are having x raised to 1, and we know that this 1 is a whole number. Okay, we have learned about whole numbers and all in the previous chapter. So we know that this variable's exponent or the variable's power is a whole number. So definitely this will be a polynomial. Okay, now look at the second one, x square plus 2. Now here the variable is x square. Okay, now look at the power of it. It is 2, and we know that 2 is a whole number. So definitely this also will be a polynomial. Now look at the second one, x cube minus x square. Here x cube. Here also the power is a whole number. Here also 2 is a whole number. Now last one also just see 4x plus 7. Here also if you see the power, okay, here the power of x is what? 1, which is also a whole number. So all the algebraic expressions whose exponent of the variable are whole numbers, we can call them as polynomials. Okay. Now let me give you a few examples which may not be a polynomial. For example, if I write x plus 1 by x. Okay. My question is this a polynomial or not? X plus 1 by x. Now you just see in a previous chapter we have learned if we are bringing something to the numerator, a negative sign will come. So this x I am writing as it is, plus this I am bringing to the numerator. So I will get x plus x raised to minus 1. Now just see this x is your variable. Now just see its power. It is minus 1. So is minus 1 a whole number? No, definitely not. It is an integer. So definitely this x plus 1 by x cannot be a polynomial. Okay. Then one more example I will give you. Root x plus 3. Okay. Root x plus 3. This is another example. In a previous chapter we have learned that this root x, how can we write this root x in fraction form? It can be written as x raised to 1 by 2 plus 3. Okay, I wrote this root of x as x raised to 1 by 2 plus 3. Now look at the variable term. X is your variable and the power of the variable is 1 by 2. So is 1 by 2 a whole number? No, it is a rational number. So definitely this cannot be also a polynomial. Here also this is not a polynomial. Now one more example is cube root of y plus y square. cube root of y plus y square. We know that. Now just see y square. Here this y is the variable and the power of that is a whole number. Okay, so that I agree. But now just look at this cube root of y. This cube root of y, how can I write it? Cube root of y, I can write it as y raised to 1 by 3. Isn't it? We have learned it in our previous chapter. Plus y square. Now here this y square, it is a whole number. Okay, but see this y, this is also a variable and the power of this variable is 1 by 3, which is what? Which is a rational number. It is not a whole number. So definitely this also, the third expression I have written, this also cannot be a polynomial. Okay, so for a given algebraic expression to be a polynomial, we have to see that whether the variable's power, is it a whole number or not. Okay, here we saw that x raised to 1, x square, x cube, x square, 4x raised to 1. All these powers of the exponents are whole numbers. But here the examples we saw, x raised to minus 1. Minus 1 is not a whole number. 1 by 2 is not a whole number. 1 by 3 is again not a whole number. So definitely these things cannot be a polynomial. Okay, I hope it is clear to you. So now the next thing we should learn is about terms of a polynomial. Okay, what are the terms of a polynomial? So if you see these things which I have written over here, this 2x. Now if I ask you what is the term of this polynomial, so I can write there is only one term in this polynomial, that is 2x. Now if I take one more example, that is x square plus 2. Okay, so if I ask you what are the terms of this polynomial, the terms of this polynomial will be x square and 2. There are two terms in this polynomial, that is x square and 2. Now this if I take x cube and minus x square. So here what will be the terms of the polynomial? The terms will be x cube and minus x square. Now if I take the next one, 4x plus 7, what are the terms of the polynomial? The terms will be 4x and 7. So basically term means how many terms are basically there in your given polynomial. That is the meaning of terms. Now if I give you one example, now if I ask you what are the terms of this polynomial, what will you write? So the terms of the polynomial will be minus x cube, comma 4x square, comma 7x, comma minus 2. Okay, these will be your terms of the polynomial. That means how many terms are there. So how many terms are there in this given polynomial? There are 4 terms which is there in your polynomial. Okay, there are 4 terms in this polynomial. Okay, so now let's see how will we represent a polynomial. Okay, we usually represent a polynomial as f of x, g of x, like that. Now, for example, if I take 2x, I will represent this polynomial as f of x is equal to 2x. Okay, here f is something which we call it as function and all, which you will be learning in higher classes. We will usually put f or any other variable g, etc. And whatever variable that we are using here will come inside this bracket. So f of x is equal to 2x, or I can also write it as g of x is equal to 2x, h of x is equal to 2x, anything I can write. Okay, similarly x square plus 2, how can I write? F of x is equal to x square plus 2, or g of x is equal to x square plus 2. Now if I give you an example, y square plus 2y plus 1. Okay, how will you represent this polynomial? We will represent it as f of y. Okay, because here the variable term given to you is y. So I will write f of y is equal to y square plus 2y plus 1, or g of y is equal to y square plus 2y plus 1. Okay, any way you can use. So this is the way in which we represent a polynomial. Let me ask you a question. We told that polynomials are algebraic expressions whose exponents of variable should be a whole number. So if I ask you 2, is this 2 a polynomial? Is it a polynomial or not? Okay, so definitely this 2 can be a polynomial. How? How can this 2 be a polynomial? We can write this 2 as 2x raised to 0. Isn't it? Why? Because we know x raised to 0, any number raised to 0. If I say 1 raised to 0, 2 raised to 0, 3 raised to 0, 100 raised to 0, any number raised to 0 is always equal to 1. So similarly, when I write 2x raised to 0, x raised to 0 means what? 1. So 2 into 1 is what itself? 2. And we have learned that if exponent to the power is a whole number, then definitely it will be a polynomial. So definitely when I say about this 2, I can write this 2 as 2x raised to 0. So x raised to 0, this power, the power of the variable is a whole number. We know 0 is a whole number. So definitely we can call it, we can say this 2 as a variable. Similarly, if I say 100, we can write this 100 as 100x raised to 0. This is again what? This is again a polynomial, because we can write the variable as the power of a whole number. Okay, so we can call such type of polynomials like this 2, 1, 3, 4, etc. and all as constant polynomial. Okay, we can call such type of polynomials as constant polynomial, where the power of the x will be equal to 0. Okay, so definitely simple numbers like this 2, 1, 3, 4, etc. can be a polynomial, and we call that polynomial as constant polynomial. Okay, similarly, if I ask you, is 0 a polynomial? Again, yes, again this 0 is a polynomial. Again we can write 0 into x raised to 0. Okay, we know any number 0 into 1 is 0 itself. So if the variable can be written to the form of a whole number as the power, definitely it will be a polynomial. So definitely 0 is also a polynomial, and we call such type of polynomial as 0 polynomial. Okay, we will call such type of polynomial as 0 polynomial. Okay, I hope it is clear. Okay, so now let's learn about classification of algebraic expressions on the basis of the number of terms. Okay, so on the basis of the number of terms, the algebraic expression can be classified into monomial, binomial and trinomial. Now, what do you mean by a monomial? So when we say about monomial, the word mono means one. Okay, so if an algebraic expression consists of only one term, we call them as monomials. Okay, just see the example: 2x, 5x cube, minus 5x square, 3y, 4t square. Okay, all these things are having only one term over here. Okay, a single term is only present over here. So we call such algebraic expressions as monomial. Okay. Now see, the next one is binomial. The meaning of the word bi means two. Okay, so an algebraic expression consisting of two terms is called as binomial. Okay, the example is, for example, just see x plus 1, x square minus x, y raised to 9 plus 1. Okay, here all these expressions there are two terms. Here x is the first term, 1 is the second. There are two terms, so this is a binomial. X square minus x square is the one term, minus x is the second term. So here also there are two terms, y raised to 9 plus 1. Y raised to 9 is one term, this one is another term. Okay, so here also there are two terms. If there are two terms in the algebraic expression, we call it as binomial. Okay, so now when I say about trinomial means there should be three terms. Okay, So here also x square plus 2x plus 1. X square is the first term, 2x is the second term, 1 is the third term. So there are 3 terms over here. Then here one more example, y raised to 4 y plus 5. Here y raised to 4 is the first term, y is the second term, 5 is the third term. So, and you know the meaning of the word try. Try means what? 3. Okay, that is the meaning. So mono means 1, bi means 2, try means 3. So now you might have understood what do you mean by a polynomial. Polynomial means it is an algebraic expression which can consist of any number of terms. It can consist of 4 terms, 5 terms, 6 terms, 7 terms, any terms. The meaning of the word poly means many. Okay, so not only when we say mono, it should contain only one term. When I say binomial, it should contain 2 terms. When I say trinomial, it should contain only 3 terms. But when I say polynomial, it can contain any number of terms. Okay, that is the meaning. So you okay, I hope it is clear. Okay, so now let's learn about degree of a polynomial. Okay, so what do you mean by the degree of a polynomial? Okay, so degree means the highest power of the variable in a polynomial. Okay, so what does that mean? Now let us take an example and understand. Look at the first one, 2x square plus 4x plus 1. Okay, degree means the highest power of the variable in the polynomial. So here we are having this x and this x as a variable. Now just see, here the power of this variable is what? 1. Here the power of this x is 2. Now which is the highest power over here? Which is the highest power present above the variable? It is 2. So the degree of this polynomial is 2. Okay, we should always see which is the highest. Okay, we should see which is the highest power. Okay, now if you see the next one, 3x raised to 7 minus 4x raised to 6 plus x plus 9. Here also the powers above the variable are, here we are having 1 over here, here we are having a 6 over here, here we are having a 7 over here. Which is the highest power present over here? The highest power present over here is 7. So the degree of the polynomial will be what? 7. Okay, similarly, one more example, 7y raised to 6 minus 4y square minus 6. Okay, so here if you see the powers present here are 2 and 6. So which is the highest power present above the variable? It is 6. Okay, so the degree of the polynomial over here is 6. So basically, whenever whatever the algebraic expression is given to you, you should observe which has the highest power present above the variable. Okay, is called as the degree. Okay, so now let's do our example number 1. Okay, so now the example number 1 is find the degree of each of the polynomial given below. Okay, so here a few polynomials have been given to you. We have to find the degree of the polynomial. So we know degree of a polynomial means we should look the highest power of the variable. So here the variables are x and x which is present. So the powers of these variables are 4 and 5. So which is the highest one which is present? It is 5. Okay, so the highest power of the polynomial over here is 5. So the degree of the polynomial will be 5. Okay, now the second one, 2 minus y square minus y cube plus 2y raised to 8. Okay, these are the variables which is given to you. So what are the powers present over here? 2, 3 and 8. So which is the highest power over here? Which is the greatest one? 2, 3 or 8? We know it is 8. Okay, so the highest degree or the highest power will be 8. So the degree of this polynomial will be 8. Now look at the third one. The third one we know 2. 2 is what? 2 is a constant polynomial. We have learned. Okay, now what will be the degree of this? I have told you that this 2 I can always write it as 2x raised to 0. We know that any number raised to 0 is always equal to 1. So 2x raised to 0 means 2x. So what is the degree present over here? 0 itself, because there is no other power given to you. So the highest power of the variable present over here is 0. Okay. So the degree of this polynomial too. Always you should keep this in mind. The degree of a constant polynomial will always be 0. Okay. Similarly, if I ask you what is the degree of this 0? Okay, we know that 0 is what? 0 is the 0 polynomial. Okay, one thing that you should be knowing is the degree of 0 polynomial is not defined. Okay, the degree of 0 polynomial it is not defined. Okay, and the degree of constant polynomial will be always equal to 0. And whenever you are be given a expression like this, just see which has the highest power. Here the highest power is 5, here the highest power is 8. And the degree of a constant polynomial it is always 0. The degree of a 0 polynomial it is not defined. Okay, these are a few things which you should keep in your mind. Okay, I hope it is clear. Okay. So now let's learn about classification of polynomial based on its degree. Okay. So now based on the degree we are having three types, which is linear polynomial, quadratic polynomial and cubic polynomial. Okay. Now linear polynomial means the degree of the polynomial will be 1. We know degree means the highest power of the polynomial. The examples are 2x minus 1, root 2y plus 1, 2 minus x. Now just see over here 2x minus 1. Here the power of each of the variable is 1, which means that the degree of each of these polynomial written over here is 1. Okay. So basically all the linear polynomial can be written in the form ax plus b. Okay. Now for example just see 2x minus 1. Here this a means the coefficient of this x and this b means the constant term. Here our b is minus 1. Similarly root 2y plus 1. This of the form ax plus b or ay plus b. Both of them. Any variable can be used. Okay. So here our a, the variable root 2 is our a, y is our x and this 1 is our constant term. Here also 2 minus x means ax. Here if we just rearrange it and write, I will get minus x plus 2. So here minus 1 into x plus 2. So here a will be a minus 1, x will be a variable term and this b will be a constant term. Okay, that is the general form. Whenever any linear polynomial we will take, it will be definitely of the form ax plus b. Okay, so linear polynomial means a polynomial with degree 1. Okay, now the next one is the quadratic polynomial. Quadratic polynomial means a degree of that polynomial will be 2. For example, 2x square plus 4x plus 3, 4y plus 5y square. Now if you see over here, the highest power, okay, the highest power here, 1 we are having, 2 also we are having, which is the highest one, 2. So if the highest power in this polynomial, it is 2. So whenever the highest degree is 2, we will call it as a quadratic polynomial. Okay, and the general expression that we use to describe a quadratic polynomial is ax square plus bx plus c. Okay, just see over here 2x square. Here this 2, this is the coefficient of x square, which is our a. This x square, this is the x square. Now bx, this b is the coefficient of x plus this c is a constant term. Okay, now the next one. Here also this 4y plus 5y square. I can rearrange it and write it as 5y square plus 4y plus 0. Isn't it? So this is ax square, 5y square. Okay, this is the 5 is the coefficient of this y square plus 4y dx plus c. Here since we don't have a constant term, I put a plus 0. So here 0 stands for the c. Okay, so a quadratic polynomial is a polynomial which has the degree 2. Okay, Now the third one is cubic polynomial. A cubic polynomial is a polynomial whose degree is 3. Okay, whose highest power is 3. So 5x cube plus x square plus 6x plus 7. In this example, we see that the highest power present over here is 3. Okay. Similarly, the general equation of a cubic polynomial is ax cube plus 5 plus bx square plus cx plus d. Okay, here if you see 5x cube, ax cube. Okay, here this x cube is your variable term and this 5 is your constant term or the coefficient of x cube. Similarly, here bx square, here this coefficient present over here is 1. Okay, so this b present here is 1 over here. Then cx. Now the coefficient of this x is 6. Okay, so cx plus d. D is your constant term over here. Okay, so this is the way. This is the 3 types of polynomials based on a degree. Okay, I hope it is clear to you. Okay, so now the last thing which you should just keep a note of it is the general expression of a polynomial. Any polynomial can be expressed in the form a n x raised to n plus a n minus 1 x raised to n minus 1, which goes up till a1x plus a0. Okay, for example, any polynomial that we take can be expressed in this form. For example, if I say 2x square plus 2x plus 1. Okay, so here if you see this x raised to n, x raised to n minus 1, these are all the degree of the polynomial. So if I say 2x square, now when I go to the next term, the degree decreases by 1. Okay, so here if it is 2, okay, x raised to n, which means x square, the next term will be x raised to n minus 1. That means it will be 2 minus 1. So here we have got it as 1. And when we go like this up till, we will get our a0. a0 means the final constant term that we are getting over here. Similarly, 3x cube plus 4x square. Here x raised to n, here the n is 3. Okay, 3 minus 1, 2. Again it will go up till like this. Then similarly here we will get 1 and finally it will go up till the constant term over here. Okay, I hope what we discussed today, everything is clear to you. So now we will meet in our next video, the exercise questions. Okay, thank you. Please like, share and subscribe the channel. Thank you.